Volume of a sphere. Now, sphere is a weird word. What is a sphere?
A ball.
A 3D circle, which we know is a ball. Are you with me? So today we're going to find out how much air or liquid you could put inside of a ball. All right. Does anybody know the formula for the volume of a sphere?
V equals 4/3 pi r cubed.
Cubed. 4/3 pi times radius cubed. All right. So what's the only thing we need to know about the sphere? The radius. That's the only letter that they've got in the formula. So as long as we know the radius, we're good to go. Okay, now by the way, a sphere is very hard to draw in 2 dimensions. Does that make sense? Because to me, that just looks like a circle. Y'all agree? Don't pop your gum. You can spit it out if you pop it again. Okay, so most artists, when they draw a sphere, they kind of put a little shading on one corner. But you're about to tell, my shading on this corner doesn't make it look any better. Does that make sense? Because I am not an artist.
Oh, I see it now.
Okay. Maybe. Anyway. Just pretend this ball's on the wall. Are you with me? Yeah. All we really need to know is the radius. So if they give me the radius of 3 centimeters, that's all the information we need to know, and we can go over here and start plugging everything in. All right, we're going to use 4/3. What are we using for pi? Are we going to use the pi button on the calculator?
No.
And let's plug in 3 for the radius. We need to what?
Square it? Oh, no.
That ain't square.
Cube.
Cube it. All right, does everybody know how to type in cube on your calculator? If you do not, listen. The little arrow, I think it's right below clear, is your power button. So when you get to this part, you're going to type in 3, power button, and then another 3. Are you with me? All right, so type it in. How do I type in 4/3?
4 divided by 3.
Times pi times 3 caret 3. Hit enter. Joseph's going to tell us what his calculator says.
I didn't see how to type in.
Oh, it's right here. It's right below the clear. While we're waiting. Oh, he threw it back. Nice.
Bentley.
Ooh, what hit that? Oh. Careful.
This is disaster.
This is the only day I allow throwing, the day we talk about balls.
Right there, bro.
You got it yet, Joseph?
You.
Dang, it ain't that hard.
Hey, 5 push-ups, like you've never struggled on something. 4/3 times pi, 3.14, times 3 caret 3. Enter.
113.04.
113.04. Raise your hand if you agree with Mr. Torres. Oh, it went off.
Is that my phone?
What's that?
It sounds like church bells.
Whose alarm? Whose phone?
You see?
This one.
What's the wallpaper?
Xavier.
Nobody cares?
I'm trying to see.
Nobody's phone? So I'll just break it then.
Oh, no.
He's got this on the
How much? How many push-ups go?
he already knows. We'll go 5.
Go ahead.
It's not like you were trying to use it as an accident, right? We'll go 5 for accident. All right, there's one thing we're missing on Mr. Torres's answer.
Cube.
Centimeters.
Cube.
Cubed. Okay, questions? All right, let's change it up. We'll leave my wonderful art drawing. What if we have a ball that is 24 inches across, kind of like those big yoga balls the girls sit on and do all the bull crap on? Okay, Tucker, what are you thinking?
It is gonna be 12 because 24 is the denominators, and if you do 12 times 2, you'll get 24, so 12 is the radius.
So take half of 24. Y'all agree with Tucker? So let's make sure that if it's the diameter, you cut it in half and use 12 inches for the radius. All right, calculator time. Type it in. 4/3 times pi times 12 to the 3rd power. We'll let Brentley tell us what he gets. We'll see if y'all like his answer. Seven, two, three. Is there a bunch of decimals?
No.
Oh, it's just a big number? For what? 0.56. Raise your hand if you like 7234.56. I think the people said you typed it in right. Very nice. We're missing something, Hasten. What else do we need on this?
Inches.
Inches
Cube.
cubed. Questions? Spheres are actually pretty easy because we only need to know one thing. What is it? The radius. All right. Pull out your IXL.
Will they ever give the volume?
Huh?
Will they ever give the volume and you have to solve the volume?
We'll find out.